Hello and welcome back to this exciting NumPy tutorial series. We have already created a video where we have talked about few commands related to installing NumPy, importing NumPy, creating a NumPy array, one-dimensional, two-dimensional, 3D, three-dimensional arrays, and then finding the dimensions of the arrays, like again, one-dimensional array, two-dimensional, 3D, how you can differentiate between them, how you can find their dimensions, how you can calculate the byte size of each element, that is what is the space occupied by the element, what are the data types of the elements in the array, how you can get the shape of the array, that is how many rows and columns it has, what is the particular value in an array at a particular index location. All this we have covered in the previous video. So if you want to go through that, you need to watch part 1 of NumPy Python tutorial. This video we'll be talking about more commands related to the NumPy library, and we'll also give you a very important tip in the end which will be very beneficial for you in the long run. So don't forget to watch this video till the very end. Let's cut to the chase. The very first command which we'll be having a look in this video is how to initialize an array with random integers or float values. Often it is required in the machine learning or data analysis process that you need to have a predefined array of a certain size with certain values, right? After that, what happens is we replace the values with the new values and then get the new array to work with. But it is often required that you have to initialize an array with some random integers or random float values. So for that, what we do is we type the command np.random.randint. Now random.randint will give you random integers. 10 is the number of integers you want, that is how many elements you want in the array, and size is 3 comma 4. 3 is the row number and 4 is the column number. Okay, 3 is the number of rows in the array, 4 is the number of elements in the array. When you run this command and then when you see what comes in the g variable, you will see that there is an array. Okay, 3 is the number of rows, that is this is the first row, this is the second row, and this is the third row in the array, and the number of columns in each row is 4, 1 2 3 and 4. Got it? So this is the significance of the size that we specify here. Now coming to 10, this is the upper limit of the integer value. Okay, so you will see that none of the values in this array would be greater than or equal to 10. All right, so 10 is the upper limit for the rand int function here. So it will generate an array which has integer values from 0 to 9 and with 3 rows and 4 columns. Got it? Similarly, if you want to create simple random float values, an array with simple random float values, then you don't need to type randint. Randint will specify that you need to get only integer values in the array. When you simply type random.rand, it will give you an array with float values where 2 comma 3 is, again, 2 is the number of rows in the array and 3 is the number of elements in each row. By default, the range of the float values will be between 0 and 1. That means this function is going to return you an array in the variable h, which will have 2 rows and 3 columns with 3 columns in each row, and the values will be between 0 and 1. Let's see what comes in the h variable. See, each of these value is greater than 0 and less than 1. None of these values is greater than 1. So this is how a random float value array can be initialized. Next, we are going to see how we can initialize an array only with zeros and ones. Suppose you want to initialize an array, but you want that all the elements in the array are either zeros or they are 1. Okay, first let's check with the zeros. Okay, so here we have a command called np.zeros. 10 is the number of elements we want in the array, and d type we have specified as integer 64. Okay, what happens is if you don't specify the d type as integer 64, it is going to give you all the zero values as float, that is 0 0.0, 0 0.0, 0 0.0. All the elements of the array I in the variable I would be 0 0.0 if you don't specify this d type as integer. And if you specify this as integer, let's see how what is the value in I. right? You get all the values at as 0, 0, 0, 0, 0. No decimal values come. But if you remove this and then you print I, see, all the values are in decimal, right? So it's not necessary that you take it in float. So that is why we generally specify the d type as integer 64. Similarly, you have a command np dot ones, where you can get an array similar to this with 10 elements, right? Instead of 10, so if you want to create an array with 25 elements, we can write 25 here. D type is again integer 64. Otherwise, again the same thing happens. If you don't specify the d type, the values will be of the float type, that is 1.1, 1.2, sorry, 1.0, 1.0, 1.0. All the elements of the array in the variable j would be 1.0. Okay, but right now, because we have specified integer 64 as a d type, all the elements are simple ones in this array. Got it? I can show you, if you remove this d type, all the elements would be 1.0. See, 1.1.1.1. Got it? So generally we take it in the integer format only, because if you remember the matrix multiplications of the mathematics part, we most of the time require a unity matrix to multiply and to do the transforms and do a lot of operations. So this is where this particular command comes into play. All right. Next, we can create an array with equally spaced values, that is equal intervals, right? For example, we want a range of values between 0 to 100 or 1 to 100, and we want the interval between each value should be equal. Supposingly, we say we want 25 values between 0 to 10 or 0 to 100, right? So it will give you an equally spaced value array. Let's see this. Okay, so first of all, here what we are going to do is, this is the lower limit 0, this is the upper limit 10. Okay, 0 is the lower limit, 10 is the upper limit. Okay, 0 is a start, or you can say the 0 is the starting point and 10 is the ending point. Okay, and d type is integer 64. Num is the number of elements you want in this range. Okay, ending point of the range. Okay, 5 is the number of elements required in this range. Okay, so what it is going to do is, it is going to create an array which will have values between 0 to 10, and all of these values would be equally spaced. Okay, see, we specified 5, so it is giving us 5 values, 1, 2, 3, 4 and 5 values, and the difference between 0 and 2 is 2, 2 and 5 is again 3, sorry, 0. Then you skip 1, you get 2. You skip 3 and 4, you get 5. You skip 6, you get 7. You skip 8 and 9, you get 10. Got it? So this is kind of an equally spaced uh, value array. Okay, if we say for example, we want to create an array with 0 to 100, between the minimum value would be 0, the maximum value would be 100 of the elements, and see, by default it is in the ascending order, and you want 25 values in the integer 64 format, then this is going to give you this kind of an array. See, so 0 to 4, you have skipped 3 values in between. Then 4 to 8, you have skipped 5, 6, 7, again 3 values in between. Okay, so here the thing is, we have asked for 5 values, but it is including 0 also. If we say 1 to 10, I think it will give us a better answer. See, 1 you have skipped 2, after that you've skipped 2, you've given 3, skipped 4, given 5, skipped 6, 7, skipped 8 and 9, and then 10, because 10 has to be the maximum value, so 10 is here. So because this is odd number, that is why it is giving an equal space in the end. But here, when you see in the num 25 one, with when the range is larger, you can see there is an equal distribution everywhere. 3 values have been skipped except for the end. Okay, because it tries to include the upper limit and the lower limit in the array. Got it? Next, we can perform different kind of operations on the array. Let's see how we can do, first of all, addition on the entire array. Okay, we are printing the original array also, and we are adding 1 to the entire array also. Now how this operation takes place is it happens element by element. Okay, I'll show you with the help of the output that we get. Okay, so see, this is the original array B, which has elements 1, 2, and 3. This is what we did in the previous video. So we created this B array. This is one dimensional array. So it has elements 1, 2, and 3. When we give the command B plus 1, to each element 1 is added. Every value, every element in the array gets incremented by a value of 1. 1 becomes 2, 2 becomes 3, and 3 becomes 4. So this is how the operation takes place. Similarly, if you try to do multiplication, b multiplied by 2, that means every value in the b array, that is 1 will be multiplied by 2, 2 will be multiplied by 2, and 3 will be multiplied by 2. This is this is same to the matrix multiplication that happens in mathematics. Alright, so the output is 2, 4, 6. Okay. Similarly, you can do division. Now C is a two-dimensional array as we created earlier, and we are dividing every value of the two-dimensional array by 10. So see how the transformation happens. C was having values 1 to 10. Okay, from 1 to 10 in 2 rows and 5 columns, right? And when we did the division, every element in the two-dimensional array was divided by 10, and the resulting array looks like this: 0 0.1, 0 0.2, and so on. Got it? Next, we will see how we can sort the values in an array. np.sort is the function which we use to sort a particular values in an array. First of all, before this, let's see what is there in the variable g, because then it is easy to compare. Okay, so I think G is a three-dimensional array. It has 3 rows with 4 columns each, right? And values, you can see how the values are. Now, when we'll run this command np.sort g, the values would be sorted. That is zeros. See here, 0, 1, 0, 9. Now, this is after sorting. This is in the ascending order: 0, 0, 1, and 9. Then 0 is 5, 5, 9. 0, 5, 9, 5, 5, and 9 have been swapped because 9 is the greatest, so it goes towards the right hand side, and 0 is the smallest, so it comes towards the left hand side. That is what sorting is, right? Sorting means arranging from lower to higher order, or from higher to lower order. When we do it from lower to higher order, that is ascending order. When we do from higher to lower order, that is descending order. Okay, in this one, 2 has come on the first place, then 3, 3, and 8 again. All the elements in every row are arranged in the ascending order. Okay, now there's another thing that we can do here is concatenating two or more arrays. Supposedly we create two one-dimensional arrays, one is k, one is l, like this, and then we use the command np.concatenate k comma l, right? Then you can see the output would be like all of the values in the k array combined with all the values in the L array. So the resultant is a one-dimensional array having all the values of the K array and the L array. Alright. Now you can have another example also where we have x variable, which is a two-dimensional array, and y variable, which is a one-dimensional array. When we concatenate both of these, right, by default what happens is the x is here is the row. Okay, the concatenation happens by the row, right, or you can say by the column. But when we say x is equal to 0, we are specifying that you want to concatenate by the rows. That is, all of these elements would be coming one after the other. Okay, and axis is equal to 1 means we want to concatenate by the columns, but this will not work because the columns are not equal in both the arrays. If this was x was also a two-dimensional y was also a 2D array, or x was a 1D array, then we could have done that. So by default what has happened is the concatenation here in the KL part, this has happened by the columns, because the number of columns was same in both the arrays, and so it has concatenated and given one single line of array. But here when we have specified the axis as 0, it is going to concatenate it by the rows. That is row 1, row 2, and this will be the row 3. But here what has happened: 0, 0, 1, 2, 3, 4, 5, 6, 7 column, and then 8th column, 9th column, 10th column, 11th column, 12th column, 13th column, and 14th column. So this one has 14 elements altogether. Then you can also reshape the values in an array. How you do that is, for example, let's store the concatenated k and l arrays in the variable m, and then in the n variable we are doing reshaping of this. Now k and l total, they have 15 values, so we are reshaping them into 5 rows and 3 columns. Okay, the first one, remember always the first one is the row, 5 is the number of row. I'm writing here so that it stays in mind. 5 is the number of rows and 3 is the number of columns. Okay, so 5 is the number of rows, 3 is the number of columns. So m dot reshape 5 comma 3. So n is the reshaped array. Now let's print both of this, print m and print n, and see the transformation what happens. See, m was a one dimensional array like this with 15 values. When we did the reshape, we have got 5 rows. Okay, and the elements are split in the same order. 11, 2 and 5, they come in the first row, because we have specified that every row will have 3 columns. Then 8, 9, 12, then 34, 31, 49, 8, 45, 56, and 23, 67, and 90. Got it? So this is how you can reshape the values of an array. Then you can also check certain conditions in an array. Like for example, you want to check that in the in this array n, which we have just created after reshaping, if any of the values are greater than 10, then this particular thing will show you. Okay, see, wherever the value is greater than 10, it is showing you true, and wherever the value is less than 10, that is this particular condition is being false, it is showing you false, right? The condition is that n should be the element in the array n should be greater than 10, or it should be equal to 10. So wherever this condition is being fulfilled, it is showing you true, like here, because the element is 11, here element is 12, 34, 31, 49, all will be true. Then 45, 56, 23, all of these values will be true, but 8 is false, right? 9 is false, 2 and 5 are false, because here the condition is not true. So this way you can also check certain conditions in the arrays. Then you can get the sum of all the elements in the array. This is particularly useful where you are when you are calculating some errors, like the root mean square error or the mean absolute percentage error. So you need to do the summation of all the differences that you get. So there you use arrays to uh, do that. So for example, n, this particular array, again n, we are going to do the sum of all the elements. When you do n dot sum, it gives you the sum of all the elements here, and the total sum is 450 of all the 15 elements in this array. Okay, if you say n dot sum axis is equal to 0, again axis is equal to 0 is the rows. Okay, so it will give you row wise sum. See, like this. Okay, so the first sum 84, this is related to 11 plus 8 plus 34 plus 8 plus 23, this is 84. Then second 154, 2 plus 9, 31, 45, 67. Okay, this is how it is. And then the third sum, that is 212, is 90 plus 56 plus 49 plus 12 plus 5. This is for this particular column. And if you do it n dot sum x is equal to 1, you will get it this way horizontally, right? The first one, 11 plus 2 plus 5, this is 18. Then you have 8 plus 9 plus 12, this is 29. 34 plus 31 plus 49, 114, and so on, right? So this is how you can do it. If you want it vertically, you can do give axis equal to 0. If you wanted to get the sum horizontally for each of the horizontal row that is there, then you can give axis equal to 1. Next, we'll see how we can calculate the minimum and maximum values in the array. The functions are pretty simple. If you give n dot max, it will give you which is the maximum element in the array. And if you say n dot min, you will get the minimum values in the array. And you can also find out the mean value by giving n dot mean function. These are pretty simple and pretty straightforward. Similarly, you have dot unique function, which you can use to get the unique values in an array. For example, we want the unique values in the m array. M was the array, if you remember here, which we created after the concatenation, this one, right? After the concatenation of two arrays in one dimensional, right? So we are going to find the unique values in this array, and then when you run this command, it will give you all the unique values like 2, 5, 8. Okay, for easy comparison, let's also print the m array. So you'll be able to see that m has certain repetitive values also, like 11, 2, 5, 8, 9, 12, 13, 35, 8, 90. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, so this doesn't have any repetitive values, but if any repetitive values are there in the array for which we are checking the unique values, it will show that repeated value only once in the unique values. It will not show it again and again, because then it will not be a unique value if it shows it again in the same array. Okay, let me show this with the help of an example. For example, we take an array O where we have defined all the values as 1 2 1 2 and 3. Okay, and then we've tried to do np dot unique of O. Now let's see what we get as an output. See, 1 2 and 3. Even though 1 was present 2 times in this array and 2 was present 2 times, it only took them once in the unique value, because unique value is only once. Okay, then we can do the reverse of an array. Reverse array is np dot flip of n. Okay, we can print it out. Okay, see, n array, if you see, let's also print the n array here, so it will be easy to compare. It was an array with 5 rows and 3 columns, right? So in reversing, what happens, the rows and columns don't change, but what changes is the order. Okay, the order, that is the fifth row becomes the first row, the fourth row becomes the second row, the third row, because this is an odd number, it will remain the same at the same position, sorry, and the second row becomes the fourth row, and the first row becomes the fifth row. So this is what has happened. Along with this, what happens is the elements within each row, they also get reversed. That is, 5 will come on index location 1, then 2, and then on the last index location we will have 11. See here, 5 to 11, 12 9 8, although here it was 8 9 and 12. Okay, so this is what happens in the reversed array. Then how you can create any convert any array to one dimensional, because what happens is you cannot do a lot of calculations on a high dimensional matrices, and in deep learning or in machine learning algorithms, what happens at the towards the end, where you want to converge all the learnings, you want to create a one dimensional array to finally have a look at all the features that you've got. So you use n dot flatten. What it will do is it will create a one dimensional array of all the values, right? We were reshaping. Remember, it is opposite of reshaping. We were reshaping it to create an array of 5 rows and 3 columns, and here what we have done is we have again flattened, or we have trimmed down, or we have made a linear array from the multidimensional array with the help of the flatten command. So that's all for this video, and here we have reached to the very important tip part, that is the end of the video. So it's not easy to remember all the commands and the parameters. You can take help from the IDE to get more information related to it. So there are certain commands which you can use, like help max. If you don't know what a particular function does, then you can use this command help, and within the bracket you can give the name of the function. So this will give you this kind of an information about the function. Okay, so you can go through this and like get an idea of what the function was, and then execute it. Next, supposingly you want to know about the min command, you can do this way, and you see on the right hand side a help pop-up comes up, and this gives you the entire information about the function or the method in the NumPy library. Supposingly you created a variable h, but you don't remember what this variable means, then you can type h with double question mark, and what this is going to give you, this is going to give you here again in the help right hand side help pop-up related to the h. It is an nd array. This is values which are there in the h array. The length is 2 because it has 2 rows, that is why. Where is the location and all that stuff. All right, and lastly, yeah, that's it. We don't have much of it. So yeah, that was pretty much it about the NumPy part of it. Don't miss out on any of the future episodes, because we'll be talking about the other libraries also in the coming sections. We'll be talking about matplotlib, which is more related to the visualization part, because visualization is also pretty important aspect of uh, the data analysis and the machine learning process. Okay, and thank you so much for watching till the end. You can hit the subscribe button if you haven't already, ring the notification bell, and join our growing community of Python enthusiasts. Until next time, happy coding and welcome to the world of NumPy Python.